trigonometric functions. Give an example of periodic behavior that you see in the environment. So I put seasonal temperatures, maybe not in Campinas, but in other parts of the world. You're going to have high temperatures in the summertime. You're going to have lower temperatures in the wintertime. In between the two, you're going to have middle temperatures. And that repeats every year, right? So that's a periodic behavior. This repetition may be called periodic or oscillatory or cyclic, depending on the situation. A periodic function repeats in a horizontal direction in intervals of the same length. Okay. The length of one repetition or cycle is called a period. So basically the width of one cycle is a period. F of x is a periodic function with period p, where f of x plus p equals f of x for all x, where p is the smallest positive value for this to be true. So all this is saying, look at this, x plus p in the parentheses. This is a horizontal translation, right? So if you do a horizontal translation, it's equal to itself. So basically, that's basically saying that the function is repeating horizontally, right? So if you have this pattern where it repeats over and over again, if you shift it by one period, then it will be superimposed upon itself, right? And then it will be, like if I shifted this one period to the right, it would look kind of like this, right? So it would be on top of itself again. If it extends to infinity in both directions, then it will be perfectly equal to itself, okay? And p is the smallest unit that we shifted over for this to be true. That would be, by definition, one period, okay? That's a really math intensive way to say it, but it's easier to think about it than to actually put a definition on it. If you put a math definition on it, that's the definition. Okay. All right, let's go up a little bit more. In a wave function, what is the equation to find the principal axis or the mean line? If you remember, the principal axis or the mean line is this horizontal line which goes through the middle of the wave. So we find that by taking the highest y value and the lowest y value, we add them together and divide by 2. That's an average, right? If we average the top and the bottom value, the peak and the trough value, it will give us the mean line value. That makes sense, right? If we add the two, add the two and then divide by 2, makes sense, right? An average. What is the equation to find the amplitude? Now remember, the amplitude is the distance from the center line or the mean line to the top or the center line to the bottom of the function. So how do we find that? We're going to take the maximum y value, we're going to subtract the minimum y value, and then we're going to divide by 2 because each of these lines is just half of the distance between the two. So we do y min minus y max divided by 2. You notice that these two are very similar to each other. Students get them mixed up all the time. Another thing that students make a mistake with is, instead of taking the y values of the maximum minimum point, they accidentally take the x values of the maximum minimum point. So make sure you use the y values for both of these definitions, and you add if you're finding the mean line because you're finding the average, and you subtract if you're finding the amplitude because you're just finding the distance from the middle to the top or the middle to the bottom. Sometimes it's easier if you do it graphically and you don't do the math calculation, then you can't get mixed up, right? I labeled a maximum point, I labeled a minimum point, I labeled the mean line, I labeled the amplitudes to the right already, okay? Let's look at 10A number 1. Which of these graphs shows periodic behavior? Again, it's a little easier just to like intuitively know what periodic behavior looks like. So I see repeated patterns here horizontally. So yes, that's periodic. What about C? Yes, I see a repeated pattern. Okay, it's always repeating the same thing over and over again horizontally. That's periodic. This, of course, is periodic. It's a sine curve. What about this? It's not repeating horizontally, right? If it was repeating horizontally, I would probably see, the same pattern over and over again, I see the pattern steadily rising. So this is not periodic. Okay. Number 3, draw a scatter diagram for each set of data below. Is there evidence to suggest that this data is periodic? Okay, so I'm going to take this opportunity to show you how you use the calculator to do a scatter plot. And then we don't have to do it on paper, and we learn something about the calculator. Okay, so first thing you're going to do is you're going to turn the calculator on, and then you're going to stat edit. Maybe this is the first time you use this, but you're going to use stat edit a lot during your math and science courses during IB. You're just going to type in all this data here. So 0, 1, 2, 3, 4, you're going to put that into L1. You're going to take this row and you're going to make it into a column in L1. Then you're going to put all the Y values and you're going to put them in L2, and you need to put them in this order. So I'm going to start doing that here, but I'm going to do most of it offline because I don't want to bore you with this. Okay, I suggest you do it on your own calculator while I do this. So I'm going to pause this and I'm going to come back. Okay, I typed in all my data, as you can see here. I made sure that I typed in the same number of elements in each column. They both end at the same row. They need to be the same length. Okay, so now I did part 1. Now I'm going to do second stat plot 1 and set up that plot. So I'm going to do second stat plot, and then I'm going to press 1, plot 1 on, and then I'm going to make sure it's set in the following way. First, I need to turn this plot format on. Then I'm going to choose XY plot. You can see there's graphical diagrams of each one. The XY plot is here, scatter plot is here. I'm going to put L1 and L2 because that's where I put my data. I put the L1 and I'm going to put the L1 as X data and the Y1 or the L2 is the Y data. As you can see, they're labeled X and Y in that order. The mark, it doesn't really matter. I'm going to use this little square. Color really doesn't matter. Now I'm just going to make sure that my data is going to be on the screen. So I need to do zoom stat. So I do zoom stat, which is number 9. And there it is, perfectly drawn. Oh, yes, so this definitely looks periodic, doesn't it? Okay, there is evidence to suggest it's periodic because I see a repetition of this pattern. It's starting to repeat here. Now, there's no data to the right, so I don't know for sure, but it's starting to repeat, okay? So that's how you use the calculator to do plot the data, okay? All right, now we're going to talk about the investigation. In the investigation, we talked about what are the roles of A, B, C, and D when we model data like this, okay? So A, of course, is the amplitude, the height from the middle to the top or the middle to the bottom of the curve. B is related to the period. We can find the B value by taking 2 pi and dividing by the period being the horizontal width of one cycle. C is the phase shift or the horizontal translation, right? So we could just like find the starting point of our cycle, and then we can just put the starting point value in for C, and that will be a phase shift. D, let me draw a picture of that so you can kind of see what that looks like. So if I have, for example, I have a cosine function, and it starts right here, and then it goes up and down. And let's say that this point is 1. Do you see how the cosine function starts at x equals 1? So I would put c equals 1, and that would, and then I would put that in my cosine c value. See, cosine x minus 1, and I'm basically saying, okay, I want the function to start at x equals 1, okay? All right, and let's see, D is our mean line value. The mean line value, and that is also known as the vertical translation. Okay, Now let's look at this last problem. Without using technology, sketch the graphs of the following for the domain 0 to 2 pi. So let's start with 3 sine x. I'm going to start with the parent function, and I didn't give you enough graph here. This needs to go all the way to 3, doesn't it? And this needs to go all the way to -3. I'm really sorry about that. The parent function of sine goes like this, right? Kind of like that, right? And then this is going to be a vertical stretch by 3. So instead of going between -1 and 1, it's going to go between 3 and -3. Okay? Sorry about that graph. Okay, now I'm going to do the same thing with 3/2 sine x. Okay, so once again, I'm going to draw, it always helps to draw the parent function first. Remember that the parent function for sine has a width of 2 pi. It goes through 0, 0, it goes through pi, 0, and 2 pi, 0. At pi over 2, the sine value is 1. At 3 pi over 2, the sine value is -1. You know that from your work remembering the unit circle values also. So if I multiply everything by 3/2, that means that the peak of 1 becomes 1.5, and the peak of the trough of -1 becomes -1.5. So 3/2 sine x would become a taller version by 1.5. Okay, so that's it for page 1. Okay, page 2. Number 2, without using technology, sketch the graphs of the following for the domain 0 to 3 pi. So here I have a grid from 0 to 3 pi. First, we're going to do y equals 3 sine x. It's easier if we first draw the parent function. So I'm going to do that first. Do that in red. The parent function, remember, has a cycle that is 2 pi long. We're doing sine, so it goes up and then it goes down. And if we're going to 3 pi, it goes up one more time. Okay, now I'm going to do y equals 3 sine x. So what does this 3 do? It's b equals 3, right? It actually makes the thing 3 times narrower because bizarro world, right? If I want to figure out what the period is, I could do period equals 2 pi over 3. So the period is going to be 2/3 pi. So instead of having a period of 2 pi, it's going to have a period of 2/3 pi. Kind of a challenge to draw that. 2/3 pi, 4/3 pi. And then finally, yeah, this is a challenge. Kind of reminds me of when I went to a sandwich shop in America and I asked them to cut my sandwich into 2/3, 1/3. And the person had no idea how to do that. And what's really funny is she asked her friend to help her with it. And the friend was Asian. I don't know if that had anything to do with it. The friend was able to do it. Okay. All right, and then finally, let's see. Okay, and then we would have this again. So 2/3. Ugh, something like that. Okay, that looks very difficult to do. Okay, then I'm going to do sine of x divided by 3. What does 1/3 do? 1/3 looks like it would make it smaller, but it's actually going to make it 3 times bigger. Okay, so what would be the period for b equals 1/3? Do you notice that this is bx, then b is 1/3, right? So that would be 2 pi divided by 1/3, which is equal to 3 times 2 pi. So that means the period is going to be 6 pi. Here we have 3 pi of a grid, so we'd only show half of the cycle. It would be like that. Okay? It's a sine curve that's 3 times as wide. We can only show half of it. All right, next one. State the period of sine of 4x. So this b is 4. If b is 4, the period is 2 pi over b, which would be 2 pi over 4, which would be pi over 2. What about this one? Here, the value of b is 1/3. So the period is equal to 2 pi over 1/3, which is equal to 3 times 2 pi, 6 pi. Okay. 4. Find b given that the function y equals sine bx, b is greater than 0, has this period. Okay, so remember, there's basically 3 ways you can memorize the formula. B equals 2 pi over p, p equals 2 pi over b, or bp equals 2 pi. Either one of these, they're all equivalent, okay? And you can use algebra to rearrange them so that they look like each other. So in this case, we want to change from p to b, right? So let's use b equals 2 pi over p. So the period is 5 pi. So we put 5 pi down here. The pi's cancel out. The b value is 2/5. Okay? What if the period is 100? Then we put b equals 2 pi over 100. We can reduce it. IB doesn't care. But if we reduce it, it's pi over 100. Okay. Moving on. Page 242. Reading. Consider the function at the right. It's just the standard sine equation. Right here, the vector which represents a translation of c horizontally and d vertically. We've seen this a couple times. I know you've already forgotten it because we hardly ever see it. But basically, it looks like this. A vector is a two-dimensional quantity, and you put the c value on top and the d value below. And basically what this does is it tells you how to translate the resulting function. Okay? All right. What is the period of the function? So the period of the function is dependent on the b value. Okay, so the period is equal to 2 pi over b. That's all we can say because we don't know what b is. All right, once we figure out what b is, we can put it into the equation and we'll find out what p is. Next one, sketch the graphs of the following for the domain 0 to 4 pi. I hope I got the grid right this time. Okay, so first of all, we're going to draw our parent function. So remember, sine goes from 0 to 2 pi. First it goes up, then it goes down. This is going to 4 pi, so I'm going to repeat the cycle one more time. So it looks kind of like that. Let's now do sine of x minus 2. Now notice that this x here is inside the sine, okay? But the minus 2 is outside. So that would be a translation, vertical translation, because it's outside the parentheses. So that means I'm going to take this red function, I'm going to lower it by 2 units. So 1, 2, 1, 2, 1, 2, 1, 2. I'm lowering all the points by 2 units. And then I'm just going to connect. Okay? And let's see the next one. The next one is the plus 2 inside the parentheses. Inside the parentheses. So that means it's horizontal. Plus 2, normally you'd think it would be moving to the right, but it's Bizaho world, so we're going to move to the left by 2. Okay? Ooh. Moving to the left by 2, that's kind of going to be a weird number to do because this grid has an x-axis in pi's, right? So like, for example, this point here, it's 3.14. When I subtract, if I'm going to move it 2 to the left instead of to the right, it's going to end up at 1.14. Okay, so that's going to be, I don't know, about here or something. Okay, this point here is 2 pi. 2 pi is about 6. If I move it 2 to the left, it's going to be about 4. I don't know, it's going to be maybe like here. So this is like very inexact, right? This is 3 times pi. That's about 9 or 10. If I move it to the left, it's like 8. I don't know. Let's see. Actually, yeah, I got to move it like more than one. I have to move it more than one grid, because one grid is pi over 2. Pi over 2 is about 1.6. So if I'm moving it to the left by 2, it's going to be a little bit more than one grid mark, right? Okay, that's better. Yeah, this is a little tricky. Wouldn't have you do this on the IB exam without the calculator. Okay, and so now I just need to complete. This one would be something like that. Okay? All right, so that was a shift to the left by 2 units. Okay? All right, this one's a little nicer. This one's a little nicer because it's in pi units, pi over 4. And now we can use this grid a little bit better. We're going to move it to the left by pi over 4. So pi over 2 is like, 1 square. So pi over 4 would be half a square. So basically we're going to take the red function and we're going to move it over by half a square. 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 Okay. Okay? Something like that. All right. State the period of y equals sine 5t. So the b value is 5. And remember, the formula to change it into period is p equals 2 pi over b. So it would be 2 pi over 5. So the period is 2 pi over 5. You can't really simplify that even if you wanted to. So what do you think? Is my writing slightly better with the Apple pencil? Maybe like 5% better. Okay, in this case, the b value is negative 2. Negative 2. So when the b value is negative 2, then it would be 2 pi divided by negative 2, and I end up with negative pi. Now, period cannot be negative, so it just becomes positive pi. Okay? Let's see. Number 3. Find b in y equals sine bx if b is greater than 0 and the period is 3 pi. So the period is 3 pi. We're going to use the formula b equals 2 pi over p. So it would be 2 pi divided by 3 pi. The pi's cancel and I get 2/3. So the b is equal to 2/3. What if the period is 50? Same thing. I put it into 2 pi over p. And I can reduce it if I want to. In this class, not really required. The only time you have to reduce in this class is when we find radian measures, right? Because we want to see it expressed in the form that we're normally seeing it. Number 4, state the transformations which map the following. So what transformation maps from sine x to sine x minus 1? So plus or minus on the outside of the parentheses, that is a vertical translation. So we're going to do a vertical translation, and we're going up or down? We're going down by 1. Okay? All right, what about C? Y equals sine x onto y equals 2 sine x. So 2 multiplication on the outside of the parentheses, that would be a vertical stretch by times 2. Okay? Next one. 1/2 sine x. 1/2 is a multiplication on the outside. Vertical. Now in this case, you could say vertical stretch by 1/2. You know that it's actually getting smaller because a stretch by a number less than 1 is going to actually get smaller. I think that this is the least ambiguous way to say it. If you say vertical compression by a factor of 2, maybe people aren't going to get mixed up by that. I'm not sure. Okay. If you say vertical compression by 1/2, then I think people might get confused. I don't know. So I think the safest way is to say vertical stretch by 1/2, because then clearly it's a compression. Okay. Y equals sine x onto y equals negative sine x. So this is an inversion, right? It's a vertical stretch by -1, which means you just invert the thing. So we're going to just do reflection over x-axis because it's vertically flipping. Finally, last one. We're going to do two things here. So the 2 on the outside multiplication is a vertical stretch by 2. And the 3 multiplying times the x is a horizontal, is a stretch or compression. So a multiplication by 3 on the inside looks like it would be a stretch, but it's actually a compression. Okay, so you could say horizontal stretch by 1/3, something like that. You could say a horizontal compression by a factor of 3. Okay, I think it's a little bit more easy to get confused. So those two are together, right? You're going to do both of those. Doesn't really matter which order, because one of them is vertical, one is horizontal. So even if you do it in inverted order, you can get the same thing. All right, that is the end of page 2.